The Nvidia 10 series of graphics cards, which launched in late May 2016 using the Pascal architecture, has been out for longer than a year at this point. Its successor, the Volta architecture, is still unavailable in the consumer market. The first card using this new architecture, the Tesla V100, was announced 4 months ago for use in data centers, and yet we've had no indication for what to expect on the next series of Nvidia desktop graphics cards. Given this lack of information, I thought it might be interesting to attempt to predict the performance of the Volta 1080 and 1070 equivalents, which I'll call the 2080 and 2070 from now on. We'll do this by comparing the 80 and 70 series of the past few architectures, Pascal, Maxwell, and Kepler, to their respective Tesla counterparts in 3 categories: teraflops, trillion floating point operations per second, pixel rate in billion pixels per second, and texture rate in billion texels per second. While this seems like a good plan in theory, it's best to test it out by using the same process to predict the performance of the 1080 and 1070 graphics cards after their release. First, we average out the performance difference in each of the 3 categories between the 980 and the 780 to their Tesla predecessors, and do the same for the 970 and 770. On average, this gives us a 17% decrease in performance between the Tesla and the 80 series, and a 38% decrease between the Tesla and the 70 series. If we plug these values in on a category by category basis, we get the following estimates for 1080 performance, which at most are off by 7% from the actual 1080, and if averaged out, we have an incredible 1.4% difference between our prediction and the actual card. With the 1070, our results are quite a bit worse, but still around the same ballpark as the actual card. We are off by about 10% every category, but if averaged out, we get a 2.7% difference, which seems more luck than anything given our per category error. Nevertheless, we have determined that we can quite accurately determine the performance of the 80 series of cards and get a ballpark estimate for the 70 series. Now we can move on to the 2080 and the 2070 series of cards. The process for this is exactly the same, except now we can also add the difference between the Pascal architecture Tesla and its little 1080 and 1070 brothers. From this, we can get an estimate for the teraflops, pixel rate, and texture rate for both the 2080 and the 2070. For the 2080, we are looking about 12.5 teraflops of compute performance, 152.6 gigapixels per second, and 390.3 gigatexts per second. This is about 39% faster than the 1080 in just about every category, which is about a 12% improvement over the 1080 Ti, with the biggest improvement being in pixel rate. The 2070 is a similar story, with a 41% average increase, leading to just under 10 teraflops, 132.7 billion pixels per second, and 301.8 billion texels per second. This also puts it about 13% ahead of the 1080, with again the largest improvement being in pixel rate. Furthermore, we can take some of Tech PowerUp's 4K benchmarks on the Founders Edition 1080 and scale the FPS by 39% to get a very rough estimate for how well the 2080 is going to perform. It seems like it should be able to drive just about every game at 4K 60 FPS, though the newest of games should be able to stress the card even more. However, do keep in mind this is speculation based entirely on the posted performance of the Tesla V100. It is mostly for entertainment purposes. Beyond that, even if we had the pixel fill rate, the texel fill rate, and the teraflop numbers, there is no way we could guess the game performance, as that varies on a huge variety of factors. This has been Darabus, and thank you for watching.